if you still remember back this visualization of the trend of the input and the output, and we state that this portion over here is the old information, right? Old information, sorry, should be like that, plus the new input, our new current input will give us our new current output. Okay, and this phenomenon is very apparent to Fibonacci system. Fibonacci system is that you have 0 and 1, alright, for the start, meaning when I start with 2 numbers, eventually I'll have a lot of numbers. What I mean is, if I have 1 and 0, 1 plus 0 is simply 1. Alright, so this first number plus this number will give us the third number. So next is I take this third number, I add up with the second number, what I have is 2. Then I take this number, I add up with the previous number, I have 3. So this new number add up with the previous number will give us the next number. So therefore, this new number is somewhat like a new input, and this previous number is somewhat like your old previous information. You get what I mean? So therefore, this is somewhat like a Fibonacci series. And the problem with this Fibonacci series is that when you plot it out, you eventually goes towards infinity. And if you have a system that is going towards infinity, this means that it's unstable. Correct? Which is not good. But it may not necessarily be the case, because some information may be negative, alright, some information may be positive, or maybe when they add them up together, they may cancel each other and things like that. So the graph may somewhat maybe be something like this, and then eventually it will die down. Alright, then it will become stable. Okay, but the problem is, how do I determine stability? How do I know that this system is stable or this system is unstable? And this is why we introduce AZK. Alright, in the time domain, for example, to the graph T and a certain gain, alright, there's always something like AEKT, some sort of the meaning. And AEKT means that you're going to exponentially grow. Alright, you can exponentially grow up or exponentially decay. It depends on the values of k. Okay, now this is in terms of the time domain. Alright, but since we know that the time domain comprises in terms of a continuous system, meaning it is not discrete. Discrete means that you are taking points, individual points in the air. You are not continuous, you didn't link them up together. That's the meaning of that. And because of this phenomenon, we cannot use the AEKT method to actually plot and see stability. And this is why in digital world, alright, where points are literally in the air, then we're gonna use AZK to plot our plot to see stable or not. Alright, and therefore in our case, AEST in terms of the UT domain is written in AZK in the UK domain. Alright, and this sentence is simply states that your current input, meaning the input that you put now, add up with your old input will give you your new input, UK. That's just the meaning. But because this thing, UK, somewhat represents the AEST system, alright, then we're going to use AZK to represent the digital system. And therefore, in order to do that, let's start to derive something to determine stability. So this is the representation of, instead of the UK stuff, this is my current input, means the input that I put in now, plus my old input that I put in the past, just the previous time step away, meaning if I put in at 2 seconds, this is the input when I put in 1 second. So when I add up together, sorry, I'll have a new input in this current second, maybe the third second, something like that. Still didn't change anything yet, just a re-representation of things in terms of AZK, and instead of AZK, previously we were UK, right? And then previously, instead of ZK K minus 1 is UK minus 1, something like that. Okay, so therefore let's continue. We'll divide everything by AZK first, and then we see how. If I will do that, this one will cancel with this one, it will become 1. Alright, and AZK minus 1 divided by AZK is simply AZK minus 1, which is this one, minus K. That's all. Alright, and plus AZK minus 2 divided by AZK is simply minus K. Alright, if I were to do that, I would have 1 is equals to AZ minus 1 and AZ minus 2 over here. So this K's actually cancel each other. Alright, so as you can see, we have no K anymore. Alright, we have removed the K. Now instead of having minus 1 and minus 2, alright, let's make things more better. I'll just multiply the whole equation, alright, both sides of the equation by z square. What I have is z square times 1, z square times this one and this one. So what I would have is z square is equals to az plus a. Alright, I should actually define as a1, a2, a1 and a2 over here. Alright, but actually this a shouldn't be here because I actually dividing everything by a just now, right? I actually divide the whole equation by a, but why do I still keep a? So I'll just remove all the a. What am I doing? So therefore I have 1. So z square times z minus 1 is simply z. Alright, because 2 plus minus 1 is z to the power of 1, which is z itself. Alright, z square times z to the power minus 2 is 2 minus 2, 0. Z to the power of 0 is actually 1. That's all. Alright, and then I bring z to all of them to both sides in order to create a quadratic equation. This one over here. Solve using any simple way of quadratic equation, the minus b plus minus, or you can put inside a calculator, or I don't think you can put inside a calculator. But at the end of the day, what do we have is we have this roots over here, alright? Z is equals to 1.62 and z is equals to minus, or maybe z1 and z2. Okay? So each of this, so after you solve the quadratic equations, you have these values over here. Now, one key thing you need to know is that UK is in fact equals to AZK. Alright, UK is in fact equals to AZK. Alright, but because this is in terms of the UK, this is in terms of the AZ system. Okay, because UK is just some notation stating that it's a new input, UK minus 1 is just stating that it's a current input, and this UK minus 2 is simply stating that it's an old input. It's just like a name. Alright, so under this name, this is itself. For example, this is a very general term. For example, this term is like human. Alright, well, under human can be a subcategory, like this is Ahmad. This can also another different equation, maybe bk minus 1 equals to another sum equation. We can call this bd. Alright, so this Ahmad equation is for this case. Alright, so this UK is simply just stating that this is just an input, that's all. Alright, a new input, stating that this is a new input, and that's it. New input can be any equations, you can use any equation to calculate. In this case, we use the z equations to calculate. Alright, I just want to make known very clear. And therefore, if such a case happen, this means that the new input UK is equals to this equation. You get what I mean? And therefore, what can I do about it? So I can simply rewrite as UK is equals to A1 Z1K is plus A2 Z2K. Okay, therefore we can simply create this formula, a1z1k plus k a2z2k, right, where you can sub in z1 and z2. And you may wonder, when I just started over here in this portion, alright, how does this link to this equation? Where the hell does this equation come from? If you were to compare, I start from this, and then now I came into this. What the hell is going on, right? The first understanding that I want to convey just now is that we said, we also mentioned that the UK is simply a new input, just the name itself only. It's just any name, like human, but I didn't define anything. It's equals to, maybe Ahmad is a human, so Ahmad is a human, equals to human. So therefore Ahmad comprises of this stuff, alright, he may have hands, legs, something like that. We actually rearrange all this stuff, alright, we actually rearrange all this stuff up till this point over here, alright. Maybe I should stop over here, and then I should bring the z square minus z equals to 1, alright. So I'm just simply taking z over to the side only. Alright, I just want to show you a certain cheat code so that you can understand what it's trying to mean over here. Why can we straight away use this formula? Alright, is example, if I were to sub in z1, because since we already found z1, we can sub in into this z's. The outcome what I will have is, maybe one I should calculate and show for you. It's like this. Alright, z squared is simply 2.62, while z is 1.62, which is what we found, and the outcome is equals to 1. Alright, now if we sub in minus 0.62 into z squared and minus z, we also have an outcome of equals to 1. Now the cheat code also comes in is that when you add z1 and z2 together, your outcome will also become equals to 1. Alright, I don't know how the equation will work, but this is something of the cheat code. So when you add them together, you'll still get back the same equation equals to 1. Alright, and this means that any configuration that we have, alright, we can either sub in over here or we can add them together. We'll always get back certain parts that is where we came from. Alright, where we came from is this equation, and where this equation came from is this equation, and where all this equation came from all goes back to this primitive one that we have just started. So as you can see, we can rearrange things in such a way that we didn't lose any detail. We didn't lose any detail from the first form of its own equation. So we rearrange all this stuff up till here. Here, this one. Alright. So in this case, then we can represent, instead of this whole thing as UK, we can represent this thing now, because this is something that we have shown you earlier. It's some sort of a cheat code. We retain the information of the original one. I retain the original information over here. This is the same thing. The outcome will be the same. But and now you may still wonder that since alright, z1 and z2, I add them up together, we should have the same answer. But what about a1 and a2? How do I get the a1 and a2 from? The a1 and a2 is simply the a1 and a2 is generated from the values of z1 and z2. Alright, so you can see the z1 and z2 is generated from all this equation. Alright, all this equation that comes beforehand. Alright, and therefore you can see the link now is that a1 and a2 will be generated from z1 and z2. So at the end of the day, a1 and a2 times z, this whole thing will eventually go back to somewhat must be equals to 1, some sort of that meaning. Alright, therefore if you don't believe me, we'll start off with something that is the initial condition, because since we know z1 and z2, so allow me to just fill in the blank over here. I actually forgot to put the k over here. Alright, so over here. So therefore, if u0 is equals to 0, u1 is equals to 1, let's sub it into the initial condition. Alright, u0 means that when k is equals to 0, u1 is when k is equals to 1. Okay, that's just the meaning. And why we pick 0 and 1? It's because if you remember the Fibonacci series, it's from 0, 1, 1, then 2, 3, right? This one plus this one is equals to this one plus this one is equals to this one. So the very first Fibonacci numbers is always started from 0 and 1, and therefore they actually use the Fibonacci number to actually prove a certain things later on you will see. Alright, so when k is equals to 0, this means that the power of this is all 0, and therefore I'm just simply going back to a1 plus a2. Okay, and if it's u1, then this means that I have 1.62 a1 plus 0.62 a2. Okay, and then I use simultaneous equation. Okay, I'll not show you how to do because it's straight away, I think you know how to do. But the result is, go there, we also forget that it is equals to 0. So for u0 the equation is equals to 0, for u1 the equation equals to 1. Okay, result is this. Okay, a1 is equals to this, a2 is equals to this. And when I sub in my a1 and a2 into this equation, at the end of the day, I would have equals to 1. Okay, you can actually try lah. You can actually try. You can also type in the calculator and you see it is equals to 1. Alright, so we go all the way around. Alright, from in fact starting from here onwards. Alright, z squared is equal to z plus 1, and then just bring this equals to 1, and then as you can see, this trend is always there. We didn't change anything. We are always changing here and there, but we didn't change. We are changing the configuration, but we didn't change any content within it. Alright, and as you can see, all the while we go through so many things. At the end of the day, we get back 1. Alright, and this is the reason why to determine stability, alright, my values, alright, should be within this unit circle of 1, should be less than 1. Alright, so this one you have derived over here. Alright, this one you have derived over here, which is throughout all this, and this one is derived from the very basic understanding of a new input is equals to the current input plus the old input. So we rearrange all this stuff, and at the end of the day we get back this. Alright, also not forgetting the Fibonacci method. Alright, so the Fibonacci method adds up and adds up and adds up. You always go somewhat. If it's outside, then means unstable. If it's inside, then it's stable. Alright, I'll not go through because in fact if we go into details, AEST is equals to AZK. So as you can see, Z is somewhat equals to ES and T is somewhat related to K. I don't know. Alright, so therefore this ES, as you can see, S can be represented in terms of as a real and a imaginary, and this can be so therefore if you remember, EJ theta is equals to cosine, this is the Euler's formula, so R cosine theta plus IJ sine theta. So this one is the real value, this one is the imaginary also. So therefore this is the same as this configuration. And just a note is that EJ theta and cosine theta and sine theta, if you were to draw, is a circle, and the R radius, alright, is simply the radius over here. So it's somewhat linked all the way back to its derivation on why do we use AZK. There is some sort of the meaning, but we didn't derive it, we just take the answer and do it up. Alright, and when we do it up, the configurations, we didn't change the things within it, we didn't change the information within it, and therefore we are somewhat mapping into this system right here. Alright, with the understanding that within this unit circle, alright, is considered stable, outside then it's not considered stable. And in the next video, we will just do a few examples. Alright, see you there.